All right, so today we're going to be doing 10.2. It's going to go a little different than yesterday as far as what I've got set up. Hopefully it works. We'll find out here shortly if it does. You know, hopefully things are okay. We'll find out. So again, I'm gonna start actually today with doing an example rather than just having you guys start working like I tried yesterday. And this example will have to do with comparing two populations, but we're going to be doing population means, right? That is the topic of section 10.2. So we're going to start with that. So I'll do an example. I'm going to share my screen. Hopefully things are going to work properly. We'll see. I'm hopeful. So I want to do this. Okay. All right, so there's that, and then that. All right, so we'll see if I can make this work out, guys. You can always follow along on the shared screen, but you guys here in person, you can just look up at the front. It might be a little easier to follow along if you catch my drift. All right, so if everything works properly, then this should be interesting. So here's our first example dealing with section 10.2. We have in a study of heart surgery, one issue was the effect of drugs called beta blockers on the pulse rate of patients during surgery. The available subjects were divided at random into two groups of 30 patients. All right. So first thing we're noticing, is this just like a survey and getting results, or is this an experiment? Based on just that first part of context. It's an experiment, yeah. Thank you. Elena, yes. Thank you, Elena. All right, this is gonna be an experiment, right? They're curious about these drugs, beta blockers. They have available subjects and they're divided into two random groups of 30 patients. So we are using random assignment, which means our random condition will be satisfied. All right, and so we want to make note of the size of each group. It's 30. They're going to be the same size, so that's kind of nice. One group received a beta blocker, the other group received a placebo. So we have our two treatments, right? So we have beta blocker and placebo, two treatments, right? The pulse rate of each patient at a critical point during the operation was recorded. The treatment group had a mean pulse rate of 65.2. All right, and that, so, we'll just call that X bar 1, right? And a standard deviation of 7.8. And that will be S1. Okay, so we're starting to label things here. For the control group, the mean pulse rate was 70.3, and standard deviation was 8.3. So we have X bar 2 and S2. Good morning. Please grab a seat anywhere you like. I have someone waiting in the audience. Oh, sorry. All right. So we've got some things going on here. This 30 patients, that will be N1 and N2. So we've got all of our kind of variables we're going to need identified from our context. The first thing we're asked to do here is find the standard error for the difference in mean pulse rate between the two groups. The standard error is essentially the same as a standard deviation, except it has to do with our samples. So when we replace all the things we would normally use with the sample values. All right, and so that formula with means, right, the standard error of x1 minus x2 is the square root of the variance of sample 1 divided by the sample size from sample 1 plus the variance from sample 2 divided by the sample size. Good morning. All right. So this is the formula that we use. All right. And notice we're using variance. We're not using standard deviation. So we're going to be taking the values we have from our context and squaring them. All right. That's the only thing we have to do. We don't have to do any fancy calculation with them. We're just going to square them. All right. So then in this context, we get the square root of standard deviation 1 squared, right, 7.8 squared, divided by 30, plus 8.3 squared, divided by 30. This whole thing is under the square root sign. All right. And then we get, if we punch this through a calculator, we get 2.08 as our solution. We're gonna want to hold on to that number. We'll need it later, right? Because this standard error comes into play when we're doing confidence intervals. It's part of our calculation for that. We've already calculated it. We're going to be able to use it without like doing calculation again. Makes that kind of nice. All right. Is there anything I can clarify about this first part A here in this question? Then we'll move on to part B. All right, so in this case, we see construct and interpret a 99% confidence interval. We construct and interpret steps. Right, we see that phrase, we're doing a 4-step process. Okay, so what's the first step? We need to state what we're gonna do. Right? That works. All right, so statement, right? We want to estimate 99% confidence the difference mu1 minus mu2 where mu1 is the true mean pulse rate of patients, similar to those in the experiment. You take beta blockers and mu sub 2 is the true mean pulse rate of patients, similar to those not taking beta blockers. right, or taking the placebo. Right, so this is what we want to do. We've identified our groups. We've labeled our parameters, what they mean in context, right? We're showing we're doing a 99% confidence interval. All the things are there to show what we're going to do next. Right? Next, we must plan. Which means if conditions are met. We will use a 2 sample. T interval. mu1 minus mu2. All right. So this is our inference method we're going to use, the 2 sample T interval. Next, let's do conditions. Random. All right. As far as random is concerned, the 2 groups are randomly assigned the treatment, so we're good. All right. Next, we get our 10%. And this one, since we are not sampling, this condition is not needed. Right? We're not sampling without replacement. Right? This is not a survey kind of thing. It's an experiment. So in this case, since we're not sampling, 10% condition isn't needed to be checked. And then lastly, we have the normal / large sample. And both sample sizes are at least 30. So the normal condition is satisfied. All right. So we've checked our conditions now. Awesome. That is the planning step. I need more space. So that brings us to actually doing calculations. All right, so we're using the T interval, which means we have x bar 1 minus x bar 2 plus or minus T star, right, the critical value, times thing that we actually already found, right, the standard error. Okay. Now we're doing a 99% confidence interval. All right, which we then need to look on table B using degrees of freedom equaling 2 29, right? So if you're looking at your shared screen, I'm not switching it over on the one at the front of the room, but if you look at the shared screen, we have our resources here. We have table A there, X part. Looking at table B, right, we find 99% down at the bottom. And we go to 29 degrees of freedom, right? And we follow this over. And we intersect at 2.756. Okay. So on the table B, we can see that that's going to be the T star value, right? That is T star. So we use 2.756 for T star. And now we replace everything with the values, right? X bar 1, if we go back to the beginning, was 65.2. X bar 2 was 70.3. Right, plus or minus 2.756 times the other number we already found, which is 2.08. Right, that was our standard error from earlier. So we get that, and we get approximately negative 5.10 plus or minus 5.73. It's okay for that first number to be negative. Right? It still tells us, in this case, as it's a negative number, it's telling us essentially that the people in that treatment group with the beta blockers had a lower heart rate. That's what the negative number is implying. And then this results in an interval that goes from negative 10.64 to 0.44. All right. So, lastly, I need a little more space. We write the conclusion. We've got our interval. And we're 99% confident that the interval from negative 10.64 to 0.44 captures the true difference in the mean pulse rates of patients receiving beta blockers during surgery and those who take a placebo. And that is our conclusion, right? Are there any questions? Anything I can clarify on this 4-step process? Getting our confidence interval. Okay. So part C says, suppose we want to test the hypothesis that beta blockers reduce mean pulse rate. State the null and alternative hypotheses for this test. So we're looking for reducing a mean pulse rate. Okay. So the null hypothesis would be that the difference is 0. They're the same. Right? It does not reduce the mean pulse rate. So we would have mu1 minus mu2 equals 0. That would be the null hypothesis. Okay. Our alternative, if we're doing mu1 minus mu2, and it's reducing, would be less than 0, which is somewhat supported by what we got in our confidence interval. We got a large section of that is negative numbers. And I say somewhat because we do contain 0 in our confidence interval. Right? We do cross over into the positive numbers. So our confidence interval doesn't necessarily support this conclusion, but we're not being asked to do this. Right? They just want the null and alternative hypothesis. Is there any questions about how I came up with these two hypotheses? Anything I can clarify? All right. So then this last part here tells us what the t-statistic is. T equals negative 2.453. We want to determine the p-value and draw an appropriate conclusion using alpha equaling 0.05. Again, I've said before, the 0.05 is incredibly common to use as your kind of like alpha value. All right, so then we have to go back to table B, find that t-statistic. We're using the same degrees of freedom, right? 29. Right, so we're going to need that on table B. Go back to table B here. We're still highlighted on 29. And we are looking for that negative 2.453, which we use the positive version. Remember, table B only gives us positive values. So we look for 2.453 or as close as we can get. All right, and it looks like 2.453 going to be somewhere in between 2.150 and 2.462. Right, so we're going to be between those two values, which means that our p-value lies between 0.01 and 0.02. Okay, if we're looking at that table B, and again, table B is on the shared screen if you're looking at that. All right, so we get 0.01 is less than the p-value, which is less than 0.02. All right, we know that the p-value is less than 0.02 based on our little interval there, which is less than 0.05. So we do get a p-value that's less than 0.05. All right. Now, when our p-value is small, right, that's what we want. Right? That means we can reject the null hypothesis. This is a result that should not have happened if the null hypothesis was true. So, since the p-value is less than alpha equaling 0.05, we reject the null hypothesis. we have convincing evidence that beta blockers reduce mean pulse rate. Now we're not entirely done writing this. This evidence only applies to patients similar to those who participated in the study. Because we did not select our participants randomly, they were volunteers. All right. So we have to add that among patients similar to those in the experiment. That has to be added. Because based on how we did the experiment, that's the only type of conclusion we're allowed to make. All right. What questions do you guys have? What can I clarify? Okay, so let's do this. I want to start presenting. Okay. All right. So now what we're gonna do is I need you guys to go into Canvas. I'm gonna share my screen here. If you go into the modules, all right, here we will, which I don't have up here. I have that on a different screen. But it is on the shared screen. Go to the modules, please. There is the 10.2 in-class practice. It is in the chapter 10 module. You can actually, I think, also click on it on the calendar for today's date. All right. If you go into that, there is an example that I'd like you guys to work through. All right. The problem is we're right there, just in directions. And again, this assignment should be done in conjunction with the class today. After I've shown you the example, I want you to solve the following problem. I want you to do your work on paper. If you do not have paper and if you do not have a pencil, I have paper right over there and I can give you a pencil that you can keep forever and ever. All right. So I want you guys to actually do this on paper. I do not want you just to type answers. For those of you live in person, for those of you at home, again, I would prefer for you to do this on paper. But if you do not have it available, typing will suffice, right? And then I want you guys to upload the picture of what you've done to this. This is our participation thing for this week because we haven't had one, all right? And you can work by yourself if you like. You can work with other people in the room. For those of you who are here live in person, you're allowed to collaborate. Those of you at home, if you would like to collaborate and work with someone else, I would like you to raise your hand and I will put you guys in groups together. But you'll need to keep your hand raised if that's something you want to do so I can know who those are. Otherwise, I expect you to just kind of work on your own. All right, so that was our 20 minutes. It's just about 9:30. So what I'd like you all to do, those of you at home and those of you here, is to take a picture and upload whatever you have done. Whether it's one thing, two things, part of a thing, that's fine. I just wanted you to submit that as your participation. Doesn't matter if you're finished. If you were simply taking notes and looking at reference things, just write that in there. I was taking notes and looking at reference stuff, all right, trying to get started. You can type that in as a text entry for your submission. okay? So even if you didn't get any part of the problem done, I just want you to submit something telling me what you used the time for, okay? And that way you get your participation for today, okay? Are there any questions before we wrap it up? For those at home or here in person or anything? Do you have a question?
Yes.
Yeah.
Are those points if we submit like half of the work?
Nope.
No?
It's just for participation, so it's complete or incomplete. Either you submit something or you submit nothing. You submit something, you get your points. That's what I'm saying. Even if you didn't get anything done per se, just type in the text entry. I was doing, taking notes and looking at reference material. Boom, totally fine. Okay. So that'll be it for today. So please submit that before logging out of stuff, like before closing up your computer and all that stuff, just so you don't forget. And I think I'm going to take one day next week to wrap up chapter 10. There's a couple of things that we haven't necessarily seen yet that I want to make sure we see before moving on. And then our other day next week will be spent on like AP stuff, as far as like making sure your computers are set up properly, looking at the testing environment, maybe doing like some practice AP things. Yeah, so that's the idea. All right, so I hope you guys all have a great rest of your day, and we will see you all next week.